Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin back again with another video from HTTP request smuggling vulnerability module, and today we are gonna see web cache poisoning via HTTP version 2 request tunneling. Okay, so this lab is vulnerable to request smuggling because the front-end server downgrades HTTP version 2 request and does not consistently sanitize the incoming headers. To solve the lab, we need to poison the cache in such a way that when the victim visits the home page, their browser executes alert 1 and a victim user will visit the home page every 15 seconds. The front-end server does not reuse the connection to the backend, so is not vulnerable to classic request smuggling attack. That means the whole setup is not vulnerable to classical CLTE or TECL vulnerability. However, it is still vulnerable to request tunneling. So request tunneling, if you want to go more deeper to understand request tunneling, you can visit this section. So basically what request tunneling is, where we want the header data into the body section. Okay, this is what we are basically going to do. So I'm just going to enable the proxy here and back to our lab, access the lab, and the burp proxy is working fine. You can see we are start receiving the request, and the first thing first, I'm going to get the web root request and send it to the repeater. Okay, so this is the web root request. I'm going to send it to the repeater. Go back to the repeater and just make sure in the inspector section the request attribute is set to HTTP2, because front-end server will receive or response with HTTP version 2 request, although it will downgrade it once it send it to the backend server. So this is important. Send the request and we get the response. So the first thing first, we need to make sure, because it is not a classical TECL or CETL or request smuggling vulnerability, so we need to make sure for the request tunneling that we can inject the fake or arbitrary headers within the request parameters, right? And we did it multiple times. So I'm going to the request headers and go to the path, and here I'm going to inject an arbitrary header. So because we are dealing with the web cache poisoning, so it's better to use the cache buster. I already described this in detail in the web cache poisoning vulnerability module. If you want to go into more detail with web cache poisoning vulnerability, you can go to the playlist of it and the whole labs are there. So basically the cache buster is used so that you can carry on your testing without hurting or affecting the normal user. Okay, so because this endpoint what you put here or the query string, only you know about that, and normal user will not get that. So I'm gonna add here one cache buster as a query parameter or query string. Then I'm gonna add here http/1.1. then I'm gonna add here new turn line feed, and I'm gonna add here one fake header. So fake header. Okay, I'm gonna apply the changes and send the request. So after sending the request, if we get the normal response, it confirms that we can inject the arbitrary headers in the request headers, and the application is responding normally fine. So after testing that, I'm gonna basically see only the header section. I'm interested in that. So go back and go to the HTTP method. So instead of get, I'm gonna add here head. So I change the request method from get to head, HTTP request method, apply changes, and back to the path. And here I'm again going to add basically for the smuggling, I'm going to add some request headers. Like the first thing, I'm gonna add here host header. So the value of the host header is going to be the exactly same what we have in our host header. So this is our host header. I'm gonna copy that and back to the repeater and paste that value. Fine. Then two turn line feeds. So shift enter, and then I'm gonna add a smuggled request, which is get slash, and let's see, here we have the blog post. So I'm going to check the post ID. So if I just click on view post, we can see the post ID is 3. So I'm going to take that, Control C, back to the repeater, paste that, and then http/1.1 and the turn line feed and a fake header. So fake header, fine. Now apply these changes and let's just send the request. I also want to change the cache buster to 2, or if you want to make it same, no problem, make it same, but it's better to change it to different value so that the cache will not interrupt or interfere. Okay, so make it 2, send it. So once we send the request, because we changed the HTTP request method to head, we should see here communication timeout. Why so? Let's see, just change the post ID. So I'm gonna choose this one. Let's say this is the 6, post ID 6. Back here, go to the path, and I'm going to change this post ID from 3 to 6. So make sure if you are getting communication timeout, try to change the post ID value and send the request one more time. It's still same, communication timeout. Let's see other post ID. Go back to this web root, and here we may get all the post IDs. Post ID 3, 6, 2. Let's try 2. Okay, apply changes, send the request, and yeah, this time we get the response. But in the response you can see the header is appended here. So you can see there is a cache mechanism implemented in between front end and back end server, and these are the proof of it. So you can see X cache is missed. That means this was the very first request and age was 0. So if I send the request one more time, you will see here hit, because this response we get from the cache and age is 25. So I'm gonna send it one more time. Okay, and I'm gonna take this, okay, cache buster, come back here, and I'm gonna add this here, paste that, hit enter. So we should see the exact same response. You can see this is the header of the appended request, okay, and rest of the things are the content. Fine. Now you can see the content length is 9081. Okay, we will see that content length here because the content length will play a crucial role in solving this lab. So back to the burp suite. That means the smuggled request is working perfectly fine, and now we need to find out an endpoint that can redirect us. So back to the proxy. Other endpoints are like academy header, but the best candidate is resources, because there are multiple things within the resources like SVG images and JavaScript files. So I'm just going to send this request, this web root request again to the repeater, and go to the repeater, send the request. It's perfectly fine. But what if we send it to resources? Okay, send the request, and you can see 302 found. And one more thing to be noticed here, that what we call the endpoint, we call only resources, and it is redirecting us to resources slash. Okay, that means if we try to execute an script here, like this with question mark. So script alert 1 and close the script tag, send the request. So it will basically add this slash automatically and redirect us. Although this will not, this script will not be executed because it is a part of the response header, but in that specific point in time, the request tunneling comes into the picture. Okay, because we want this header data into the body so that the script can be executed. Fine. And for that purpose, what we will do, back to the request header, actually here, and I want to change few things, like instead of this post ID, I'm going to put here resources and question mark. Actually the same thing we write here, so I'm just gonna copy that, Control C, back to our smuggled request, and instead of that I'm gonna put here this one. Fine. And change the cache buster if you want. So if you are testing quickly, where you make some specific, you try some specific things, and next time within 30 seconds or within 10 seconds you send another request, so at that instant the cache will make the problem. So at that time, if you are testing things after 30 seconds, so no problem, with the same cache buster you can do it. But if you want the cache will not interfere with your different testing request, make sure you change the busting ID. Okay, so 3, and everything's perfect. Apply changes, send the request. Now this is the thing, this is the part where the content length plays a crucial role, because you will get here communication timeout. Why? Because the number of bytes in the response expected by the server is not exactly the same or more than that. So we need to add here padding so that the content length will be same as it requires or more than that. So for that purpose, if we come back here, you can see 9081, or if we go back to the proxy, to the web root request, here you can see in the response the content length is 8757. So we need to generate a string with 8757 characters, and for that purpose I'm gonna open the prompt here, and I'm gonna use pwgen. I already used it before, 8757, and I'm gonna save it as a file, 8757 underscore characters.txt. okay, now 8757, this is the file, and I need to copy all these content, copy, and back to our repeater. Here after the script we need to add this content. Fine. There is a problem with this, so it seems perfectly fine. And after that padding characters, just there should be a space, and after that http/1.1. this is fine. Now I'm going to apply the changes. If you want, you can change the cache burst value or ID, because the 30 seconds already passed, so this is gonna be the new cache response saved in the cache, no problem in that. Send the request. You can see now the padding value is also appeared here in the response, and that means the tunneling is working perfectly fine. So if we go back here, and instead of 2, if I change it to 3 and send the request, you should see the same thing here. You can see the alert pop up here, and that means the script is executed and the request tunneling is working perfectly fine. And you can see this is the complete padding characters. Fine. So what we need, everything is working. We just need to remove this because everything is tested and this is the time now. We need to deliver this exploit to the victims through the cache poisoning. I'm going to delete the cache buster and I just want the web root endpoint here, because what the lab is saying is the front-end server does not reuse. Okay. To solve the lab, poison the cache in such a way that when a victim user visits or victim visits the home page, so home page is published over web root, and just apply it. Fine. And send this request one time so that the response is saved in the cache. And then once the victim access that, we will solve the lab. So I'm going back and take this out, access the web root or the home page. Back here you can see the response is perfectly fine. We need to, and yeah, the alert is popped up and hopefully we solve the lab. So if I open the new lab, alert is popped up. Keep sending the request because the victim user is accessing the home page every 15 seconds. So this timing also need to be perfect. Okay, congratulations, you solved the lab. That means the victim user accessed the home page and the alert is popped up on his browser. Fine. So that's it. We solved the lab and I hope you enjoy the content. If you like the content, please like, subscribe and share. I'm going to see you in the next video. Bye.